Hey everyone, welcome back to the channel. Today's we are diving into the fascinating world of fine-tuning the neural network hyperparameters. So by the end of this video, you will know not only how to tweak these settings, but also what are hyperparameters and also how to analyze this result graphically. So we'll use Python, Bit, TensorFlow, and Matplotlib for this demonstration. So let's get started. First thing first, like what are hyperparameters? So hyperparameters are knob and tiles you can adjust to optimize the performance of a neural network. So this includes setting like the learning rate, batch size, number of epoch, and the number of neurons in the layer. So unlike weights which are learned during trainings, hyperparameters must be defined before training begins. And fine-tuning hyperparameter is a systematic process. It involves selecting the set of hyperparameter before the hyperparameters, training the models and evaluating its performance. And by comparing the result, we can identify the best configuration. So let's see how this works in practice. So first we'll set up the neural network. Let me import the libraries. So we'll use MNIST dataset, which consists of the grayscale image of handwritten digits, right? So let me load the dataset. And here the function create model. Let me run this. So allow us to define simple neural networks with customization hyperparameters like hidden units, the learning rate, right? We are taking two input for this function. And the model consists of the flattening layer, a dense hidden layer with RUL, LU, and the activation, and the output layer with software activation for multi-class classification. Next, we'll set up the experiment to fine-tune these hyperparameters. We'll evaluate the combination of each values for a number of hidden units and learning rates. So for hyperparameters, let me run this. So there are two for loops which will run for each hidden units and for each learning rates. So in this script, we loop through combination of hidden units and the learning rates. So each model is trained for 5 epochs with a batch of 32. And 20% of the training data is used for validation. The final validation accuracy is recorded for each combination, and that we will visualize in the next step to see the results to understand the impact of these hyperparameters on the model performance. So this will take some time. We'll just pause here and we'll come back. Okay, so our execution is completed. Now let's move to the next cell and let's plot the result for this. So now let's visualize the results to better understand the impact of these hyperparameters on model performance. So we are creating the scatter plot for this. Let it run. All right. So the scatter plot these provide a clear visualization of how validation accuracy changes, right, with different hypermeter combination. So each point represents a specific combination of hidden units. So on the x-axis we have hidden units, and on the y-axis we have a learning rate. So each point represents a specific combination of hidden units and learning rates, and the color intensity indicates the validation accuracy with darker points showing the better performance. Right. So from the plot, we can quickly identify trends. For example, the model with higher number of hidden units might generally performs better, but learning rate also play a crucial role. So too high or too low a learning rate can negatively impact performance. This analysis helps us pinpoint the optimal range for these hyperparameters. And there you have it. So fine-tuning hyperparameters is a crucial step in optimizing the neural networks for better performance. By systematically experiment and analyzing results, you can unlock the full potential of your models. So I hope you find this video helpful. Thank you for watching. I will see you in the next time.